Hey guys, it's Joe with LVV. So we're working on a Rheem furnace right here. And we have power coming in. 115 here. 115 to the board on this white and this black. I'm sorry, I was showing you. 115 here and here. Okay, so 115 is coming in, going through the black and the white right here. And going to the white on the board here, the black there. So we have 115 here. Go into the transformer, and then 27 right here, which is great, but the board's not firing up. You know, we got nothing at the LED down there. See, where is it? Where are you? All right, there, peekaboo. There you are. Nothing there. So now we have our. Where's the filter? I mean the filter. Where's the that fuse? Where'd that fuse go? So we got this fuse over here. And it looks like, if you look through it, I think the fuse is no good. So we're gonna do a continuity test. So can we hold that? Let's see here. Put one on each one. One on each. Right there. We're supposed to be getting some buzzing. Yeah, see? That fuse is bad. This is a brand new install from last year, so I don't know if somebody took the thermostat off the wall maybe. Touch the common and the R together. Maybe pop the fuse. That's a possibility. So we're going to change the fuse and see what's going on. We'll have to put an amp meter over here and see if the amps are riding high. Maybe a bad contactor. Hopefully it's just that the homeowner just changed the thermostat. Did something to it, I don't know. All right, well, we'll have to check. Any loose wires or something like that. But if there's more amps, you know, if there's more than 3 amps going on to, you know, on this board, it's gonna pop that fuse. So we'll let you know. All right, guys, it's a little loud here, but hopefully you can hear. If you're in this industry, you need to get yourself a popper, okay? 3 amp and a 5 amp. You see it right there? It says 3 amp circuit, 24 volts. You basically take the fuse out of the link, right? And then you just put this in, okay? You make the wires a little wire, a little longer. You have the female here, the male there, all right? And then and this will just pop. And this is good for testing. Okay, so what we did was outside we disconnected the compressor. All right, so normally when you do this, it's normally like the contactor. Okay, so we took the 2 wires off the contactor. All right, which basically come from here. All right, this is the 24 volts, and then we have it down here. The Y and the C goes up and outside, and it's connected directly to the contactor. So we're going to take a look at the contactor, hold it out, and make sure that there's not a direct short inside that contactor. But we're going to take a look. So what you do, though, is you start taking things out of the circuit. We undid the 24 volts on either side of the contactor, turned it on, fan turned on. So we know that no problem is here. All right, that problem is strictly outside. All right, and it's popping the low voltage. So normally the low voltage problem is going to be a contactor. All right, so when you go outside, do a Holmes test, I'll show you that. And probably end up changing that out. So let's see how it goes. All right, guys. So we're outside, and what I'm doing right now is I'm doing an ohms test. See, I'm going on either side of the coil. That's 0.4, which is 0.3, 0.4. That's kind of low. When you get down to like 0, 0, okay, then you have a dead short, and I think that's what's going on. This contactor, the coil, I think is no good. So if we do open it up, we're going to probably see. Can't see it here, but you'll probably see like a burn mark. So I think either one of both sides of these, okay, there's like a winding inside, and something is dead shorted. I think there's a dead short on there. So we're gonna change it out, and I'm pretty confident that that's the problem. Because if you push in the button, you depress, it's totally fine. But right when it gets power to push this in, all right, I think that 24 volts is. I think they're touching each other inside that coil. all right? Because it's not popping the main breaker or on either unit. It's just doing the 3 amp fuse. And a lot of times, this is it. All right, guys? I'll change it out and we'll take a look. All right, guys, so now we're just gonna test just the coil, okay? So look, we have nothing connected, just the coil. So if the coil was bad, see how it clicked in? All right, and it's still running fine. See, if I take it off, if it was popped, it wouldn't be doing this. All right, now, when you're, just a little teaching, grab one. All right, go on this side. So when this is open, you have nothing here, okay? You see that? I'm on continuity down there, nothing's happening here. Once the air handler or the thermostat tells the contactor to close, now, go ahead. You see that? Now the lines go through. Put it on the other side too. Over there, on the other side. You see that? I'm not sure if you can see it. There you go. So that it connects right inside here. All right, guys? Now we do it again. And it opens. So when the thermostat opens, 24 volts stops coming in between here, and it stops to magnify this coil. All right, so sometimes this coil gets all screwed up, and then it'll pop. Now, for any reason, this should be the problem, because if there was a problem here, that's the high voltage, the main breaker would be popping. This here is low voltage, and that's what's popping down there. So this is the only thing that's in the circuit that would pop that. All right, other than the other stuff other than the fan inside there, which is spinning right now. So I know it's this right now, that little coil. So whenever you get the 3 amp fuse popping on you guys, check out the coil on that contactor, okay? And I guarantee if you opened it up over here, you'd see like a black dot or a burn mark or something like that. Just change them out. Make sure that you have the same coil. You have to make sure that the what is it? See, this is 240, 277, and that's a 30 FLA, and then the resistance is 40. It's this one over here. This one here is instead of 40, it's 40, but it's got a 35. It's got a 35 instead of a 40, so this is a stronger contactor. It'll be all good. All right, guys. So I'm gonna change it out, wire it back up, and I'll show you the unit running. All right, guys. So now, what we said it was bad contactor. This contactor had a 0.0, it was 0.04, 0.4, right? Something like that. 0.4 on it, which means if it goes down to 0, it's a dead short. So the resistance in these coils should be like 0.14, 0.16. All right, the higher the resistance, the lower the resistance, the worse it is. All right, and then eventually it's a dead short, and that's what it was doing. So see, unit's running, we're all good, nothing's tripping. Bad contactor. I would say 9 out of 10 times it's a bad contactor. All right, when it pops on the low voltage side. Okay, if you got that board tripping or the transformer burning out or something like that, what you do is you start unplugging. Unplug the compressor. You unplug that contactor. Reset it. Turn it back on. And if everything is good, okay, just go get another contactor out of the truck and plug that in. If it clicks down, that means the coil is bad on the old one, and the new one should be totally fine. Because if it was popping because of the unit, that'd be on your high voltage. That'd be the main breaker at the panel, not the low voltage at your 3 amp fuse. All right, guys. So bad contactor. You have to make sure you get that 3 amp or 5 amp. Different units have different amperage. 3 or 5. Popper, because you don't want to just keep on going through. You want to keep on going through fuses. It'll get expensive and annoying. All right, guys. So LVV out, and we'll see you guys on the next job.